Hi, my name is Teddy.
My name is Raquel.
I'm Michael.
I'm Robert.
I'm Mohammed.
We are Group 33, and our project covers the topic of hydrofoil ships and lift. Hydrofoil ships are high-velocity vessels that use lift to completely raise out of the water to reduce drag. We specifically will cover the AC-72 hydrofoil, a competitor in the America's Cup. Our presentation asks the question, what minimum velocity must a hydrofoil ship go in order to lift out of the water? We hypothesized that using the lift equation, we could determine the velocity to lift the hydrofoil.
Our assumptions were that the fluid is incompressible, the weight of the boat is 5,900 kilograms, and we also assumed that there's 11 crew members on the board, each weighing approximately 62 kilograms, so bringing the whole weight of the boat and people to 6,582 kilograms. AC-72 travels at maximum velocity of 22.5 meters per second. We assume the dagger board is thin, so we can use the equation for the coefficient of lift 2 by radians. The lowest angle with the max velocity is 3 degrees. The highest angle to lift the boat is 15 degrees. We got all the equations and the radians from the MIT page.
Hydrofoil wings are similar to the concept of airplane wings. Once the lift is large enough, the ship will lift out of the water. If an AC-72 produces too much lift, the craft will fly out of the water and crash. By altering the angle of the dagger boards, the coefficient of lift is altered, thus allowing for higher velocities at lower degrees of attack. This maintains a constant lift force, keeping the craft in the water.
From the NASA website included in the reference slide, we got the lift and lift coefficient equations that can be used to determine the area of the hydrofoil dagger board. At the maximum velocity of 22.5 meters per second, and the corresponding angle of 3 degrees, we can determine an area of a 0.78 meters squared. From there, we can use this constant area and the 15 degrees angle to determine the minimum velocity to lift the boat out of the water.
We concluded that about 10 meters per second was the velocity needed to lift the hydrofoil ship. Below 10 meters per second, part of the boat will be in the water until it reaches this velocity to lift. We were correct in assuming the lift equation with our assumptions would allow us to determine the velocity needed to lift the hydrofoil ship out of the water.